Hey there! So the last video covered the basics of orbital mechanics using a theoretical circular orbit. This video is a continuation of the same, looking into more concepts such as orbital periods and orbital radii. Let's get spacey. Orbital period is simply the time it takes for an object in orbit to complete an entire orbit. Using the formula speed is equal to distance over time and rearranging it, we get equation 1 for the period of an object in orbit in terms of distance and speed. The distance can be calculated using the formula for the circumference of a circle, equation 2, and the formula for orbital velocity derived in the previous video, equation 3, can be used for the speed. Putting this together, we get this equation. And the key thing here is that the square of the period is proportional to the cube of the radius, or the size of the orbit. And this, in fact, is related to one of Kepler's 3 laws of motion, which we will discuss in a future video. This phenomenon is actually observed by astronauts on the space shuttle, where astronauts on missions at a relatively lower altitude, like that of the International Space Station, experience shorter orbital periods than those who went higher up to the height of the Hubble Space Telescope and experienced slightly longer orbital periods. Alright, now, let's see how this formula can be applied to a key concept in real life. One of the many different types of orbits that we have named for our convenience is the geostationary orbit. It is simply when a satellite stays above a fixed point above the Earth. This means that the period of the satellite in orbit needs to be the same as the rotation of the Earth, which is 24 hours. Plugging this value of 24 hours into the equation for the period, we find that the distance from the Earth for a satellite to be in geostationary orbit is 42,240 kilometers. Geostationary orbits are key in enabling things such as satellite TV, where the satellite dishes on Earth remain pointing at a fixed direction in the sky, which is where the satellite is in geostationary orbit. Well, that's it for this video and our look into orbital mechanics. Stay tuned for our next series on Kepler's laws of motion. Be sure to like and subscribe and help this channel grow. I'll see you in a bit, and until next time, stay spacey.